Radicals are numbers just like any other number, but we kind of treat them as a little bit of a hybrid between a number and a variable. I can't, for example, subtract radical 3 minus radical 2 because they're not the same radical. They're not like terms. They're not square roots of the same thing. I can't take this and say that that's equal to radical 1. That doesn't work. Be nice if it did, but it doesn't. That's not how radicals work. Which means that just like when we distribute something like x plus 6 times x minus 7, by doing the double distribution, we do x times x minus 7, and then 6 times x minus 7, the whole pizza and wings method that your teacher might have mentioned. When we are distributing radicals, when we have things like this, then it's the same thing. We have binomials with radicals in them. We treat them exactly the same way as we do if there aren't any. We do the double distribution. So I'm going to take the 2 root 6 and distribute that to the root 3 minus root 2. And then I'm going to take the radical 5 and distribute that to the radical 3 minus radical 2. And of course, when we're distributing a single thing, we just take that and multiply it to both parts. So 2 radical 6 times radical 3, I multiply the radicals together, I get 2 radical 18. 2 radical 6, 2 root 6 minus root 2, root 6 times root 2, 2 root 12. And then here we have plus root 15 minus root 10. And now we simplify. Again, this is an important point. Don't forget about that step. Whenever you've combined radicals, whenever you've multiplied them together, or divided them together, or even if you've added or subtracted them, always make sure that none of the radicals can reduce. None of them can simplify, I should say. Radical 18, square root of 18, hopefully, again, you should be picking up on this pretty quickly by now. That, radical 18, is equal to radical 9 times 2. Which is radical 9 times radical 2, which is 3 root 2. So 2 times 3 root 2. The root 18, square root of 18, simplifies to 3 root 2. Minus 2 times 2 root 3. I'll leave that simplifying as an exercise for you. Suffice it to say, square root of 15, square root of 10, they don't simplify. And so my final step is to multiply these things. So we get 6 radical 2, multiply the coefficients essentially, minus 4 radical 3, plus radical 15, which doesn't reduce or simplify, minus radical 10, which doesn't reduce or simplify. I can't combine any of these. I got a 2, a 3, a 15, and a 10. And so while it's not very pretty, that's my final answer. Just a quick warning and a reminder about squaring things. While it is true that the square of 7 root 3 is equal to 7 squared times the square root of 3 squared, do not overgeneralize this. That is a shortcut version of what really is happening. What really is happening is that we have 7 radical 3 times 7 radical 3. And that's what ends up giving me the 7 squared and the radical 3 squared. The point that I'm trying to drive at here is that if that's, for example, 7 plus the square root of 3 squared, this is not 49 plus 3. This is not 7 squared plus radical 3 squared. This is not true. Don't make this mistake or your teacher will be very upset. If your teacher's anything like me, there's a couple mistakes that really bug them, and that's mine. Remember, what this means is that I'm taking 7 plus radical 3 and then multiplying that by 7 plus radical 3. And if you remember your shortcut for squaring, we have 7 squared plus, on the end, radical 3 squared, And then in the middle, we have 7 times radical 3 plus 7 times radical 3. So we get 7 radical 3 twice, so 14 radical 3. And so as my final answer, what is that? I get 58 plus 14 radical 3 as my final answer.